Here's a dividing rational expressions problem. Another word for rational expression is usually a giant fraction. So here we have two giant fractions, we're dividing them, and we have variables, we have x's in them as well. So what we're going to do is we're going to factor the tops and bottoms of each fraction, cancel everything out in the end. But before I do, you see how we're dividing? We want to change that into a multiplication. That's going to make the problem much easier. So that's where we have the keep, change, flip. A lot of people know that is KCF. I keep the first fraction. I'm going to change that sign into multiplication. So I'm going to change it to a multiplication dot there. And then we're going to flip the second fraction. So what I'm going to do is I'm going to rewrite out the problem over here. I'm going to factor as I go along, and then my last step, I'm going to go ahead and flip this while I'm factoring. So looking at just the top of the fraction, focus on little pieces at a time, little bits at a time. Looking at just the top, I have to factor that out. I know I'm going to end up with two sets of parentheses. If you're not sure how I'm about to do this, go ahead and look at factoring quadratics, and that'll explain it for you. X squared times x squared, the two numbers that we multiply to get that are x and x. The two numbers that multiply to get 16 and add to get 8 are positive 4 and positive 4. On the bottom of this fraction right here, I have an x plus 3. It cannot be factored. There's nothing more we can do, so I'm just going to leave it as x plus 3. Now remember how I said I was going to change this to a multiplication. I'm going to be multiplying now. But when I factor out my second fraction, this top part is now going to end up on the bottom. I'm flipping the fraction. Because when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So I have to flip the fraction. So looking at just the top over here, I'm going to rewrite that on the bottom. The GCF of the top is 2. So notice how I'm writing that on the bottom even though it started out on the top. And then when I divide each term by 2, I'm left over with x plus 4. On the bottom here, there's no GCF. I can't use the x factor, but it's that special type of factoring that we've talked about before. We're subtracting two square numbers. That's the difference of squares. So because that starts out on the bottom, I'm going to factor it out on the top. The square root of x squared is x. The square root of 9 is 3. And my signs are plus minus. So the hard part is over. Now comes, personally, my favorite part. Just cancel everything out as long as there's one on the top and one on the bottom. So we're using cross cancellation. So this x plus 4 down here cancels out with an x plus 4 up here. The x plus 3 down here cancels out with the x plus 3 up here. I do believe that's it. I don't think there's anything else. So I'm going to go ahead and multiply whatever's left over on the top with whatever's left over on the bottom. So I have x plus 4 and x minus 3 on the top, and on the bottom the only thing left over is 2. So that leaves C as your final answer. Make sure you cancel everything out all the way because D is the same as C except it's not simplified correctly. It's not simplified all the way. So C is your final answer.